Ladies and gentlemen, welcome to our presentation on the exercise 2, Schema, Matching and Mapping. We are Supergroup 3. In our initial situation we had three companies, Couch Cinema, Dolly Blockbuster and BDMI. Couch Cinema and Dolly Blockbuster are two businesses following the same business model, a movie rental service. In order to face the strong competition in the market of classic online movie rental services, e.g. Amazon's LoveFilm or iTunes, Dolly Blockbuster and Couch Cinema needed to combine their customer base and streamline their services. Therefore, they decided to merge into one company. Additionally, they chose to expand their services by acquiring BDMI, an online movie database which allows its users to rate movies. Consequently, the three companies are migrating not only their databases but also their business software. Now we are at the end of this big migration project. The whole business software is already migrated and ready to be rolled out. The only thing missing is an integrated database to work on. For the future, all work will be done on the new mediated schema, thus the ETL process will only be run once. Creating a mediated schema from our three different database designs exposed us to several conflicts. But first of all, let's have a look at the three legacy data models and afterwards the mediated schema which resulted from them. The entity relationship model of Couch Cinema contains the basic entities which are required for this business model. There are movies, of which several mediums exist, which again can be rented by customers. The Couch Cinema customers get billed based on a monthly fee for their subscription. In contrary to that, Dolly Blockbuster raises fees related to specific rentals. There is no direct connection of fees to a customer. Another difference is that Dolly Blockbuster movies are furthermore divided into editions, so there can be extended cuts or 3D versions of the same movie. Also, Dolly employs an inventory system in which every object contained in a movie copy is individually maintained in the database. Apart from that, both database schemas are very similar in their basic structure. Due to its different business model, BDMI's database schema differs substantially from the others. Main connecting points to the Couch and Dolly schemas are the customer or user, the movie entity, and its connections to genres and ratings. Based on these connecting points, we can create a mediated schema incorporating every aspect of both worlds. Let me present to you our mediated schema. For better overview, we have divided it into three main parts. The green one contains the customer rental and payment system, mainly derived from Couch Cinema. The blue area consists of the detailed movie data structure of BDMI, including the edition system of Dolly Blockbuster. Last but not least, the orange part displays the inventory system derived also from Dolly Blockbuster. Due to constraints in terms of presentation time and relevancy, we will only present transformations that we deem specifically interesting. Let's have a look at the movie section. BDMI and Dolly Blockbuster designed the movie entity in a very similar way. The tables include a release date, a description and a title column. Couch Cinema, however, came up with a different interpretation. Their movie entity directly represents physical manifestations of a movie and therefore stores the respective amount of discs and bonus discs. The merged schema assumes the column's title, release date and description. Couch refrained from storing a description which is replaced by a null value in the mediated schema. Another diversity is related to the release date. Couch's release date is stored as a year type. We transform this into a date type using the 1st of January to replace the missing month and day. All records are written to the merged movie table, which has an auto-generated ID. This auto-generated ID is written back to a mapping table, referencing the original ID. The movies from the other source systems are matched on the existing titles using the Levenstein algorithm with a threshold of 2. In case of a match, the related record in the mapping table is updated with the ID from this source system. Otherwise, a new movie and a new mapping record are written into the table. As we decided to go along with the implementation of editions from Dolly Blockbuster, we need to create corresponding editions for all those movies from Couch Cinema and BDMI. We chose to create a standard edition for all movies without an edition. Furthermore, we kept the year of publication from Couch Cinema and set it as the release date of the edition. Couch Cinema only has DVDs in their repertoire, and BDMI has no physical copies of movies and does therefore not specify the medium type. That's why we set the data medium of those movies to DVD by default, since it can be assumed that there is a DVD edition of every movie. Also, we set the price category to the standard DVD rate for all newly created editions. We chose this approach and assumptions because, otherwise, a manual entry of the data would be unavoidable. We thought it makes more sense to import everything and then enrich the data step by step through the employees. Next, we wanted to create actual person records from the cast attribute of the Dolly Blockbuster movies. After we got the actual movie ID, we split the string cast with a delimiter, comma with space. As a result, we have an array of strings. Then we can generate new output rows by cloning the input row for each element of the array and replace the cast field with the person's name. Additionally, we have to skip the processing of the input row. As a result, we have an output row for each member of the cast with a single name in the cast field. Afterwards, we tried to find matching people in the person table. Therefore, we used the Levenstein algorithm with a threshold of 2. If a person has no match, we need to create a new person. Then we can generate an entry in the isActorIn table to establish the correct relationship between the person and the movie. Alright, let's move on to another section of our mediated schema and have a look at the inventory objects. As just Dolly Blockbuster and Couch Cinema are video rental companies, they are the only ones to have copies of each movie. The main difference between both of them is that Dolly Blockbuster links their copies to editions, while Couch Cinema links it to movies, as they do not have editions. Therefore, we created first of all a joint copy table with the referring copy mapping table to be able to find the copy by their former ID as well. In order to set the corresponding edition ID in the newly created copy table, we joined the copies from Couch Cinema with the movie mapping table, and search with the ID of the movie the corresponding edition. Additionally, Dolly Blockbuster has inventory objects which represent single discs or VHS. As this structure enables us to monitor damages on every single item we have got, instead of just a DVD box, we decided to go with this implementation. So we created inventory objects with the help of the movie attributes of Couch Cinema's number of discs and number of bonus discs. We assigned the inventory type DVD and bonus DVD, as Couch Cinema only has DVDs in their repertoire. Now we would like to show you a little something that we did with our customer records. Let's have a look. All three companies use a customer or user entity in their database model, which are similarly structured. Being a service that does not physically interact with its customers, BDMI does not store address information. Couch Cinema, on the other hand, does not store a username or an email address. All of the attributes from the three entities were assumed in the mediated schema. Let us take a look at a few notable problems we had to overcome in the process. In contrary to the other two companies, BDMI doesn't store the customers' names in two separate fields for first and last name, but in one. To transfer BDMI customers to the mediated schema, JavaScript is employed to split up the name by whitespaces. This script can also identify surnames that consist of more than one word. The Couch Cinema schema does not provide usernames, passwords or emails for its customers, since these fields are supposed to be not null for the sake of their future use by the business logic, for instance. We decided to create usernames by concatenating the first 4 characters of the first and last name, as well as the first 2 digits of the zip code. For security reasons, we want our passwords to be stored MD5 hashed. Also, we are employing salts in order to secure passwords even more. Therefore, we are creating a random string as a salt for every BDMI and Couch Cinema customer. Then we are MD5 hashing the existing BDMI passwords as well as the ones automatically created for Couch Cinema customers, together with their respective salt value before mediated schema. After we imported all customer data into the mediated schema, we saw that some of the geofields, city, region, country, were empty at a lot of our customers. We decided to use a third-party geodatabase, geopostalcodes.com, to increase our data quality. Fortunately, we only have customers from Germany, and most of the customers have a zip code set. This allows us to fetch the relevant information from the geodatabase by zip code and replace the null values with the correct values. Now let's move on to our next topic. We are going to look at the transactions and the transaction types. Since, again, only the two movie rental companies, Dolly Blockbuster and Couch Cinema, are dealing with customers' payments, only the two data models have to be migrated here. Due to the different implementation of transaction and fee types, we perform a transformation and mapping of the attribute transaction type and the existing entity fee type to the newly introduced entity transaction type. In the first step of the transformation, we basically copy all fee types from the Dolly Blockbuster database to the final schema as transaction types. To allow mappings of relations, a mapping table is introduced. In the next step, we gather all distinct instances of transaction type attributes from the Couch Cinema database. Since these are strings and in underscore notation, we decided to use a JavaScript modification to allow easier matching with the named fee types from Dolly Blockbuster. After a filtering step, the existing mappings were either updated or new rows were created along with the new transaction types from Couch Cinema that have not been present in the original Dolly Blockbuster database. Continuing the financial part of the models, we have to merge existing fees from both the Couch Cinema and the Dolly Blockbuster databases. Considering the preceding transformations of customers, rentals, and transaction types, that task is quite straightforward. At first, the fee-specific transaction type has to be looked up via the previously created mapping table for both database input streams. Due to the different business models of the two companies, there is a slight differentiation to make in the following steps. While rows from credit balance or fees in the Couch Cinema model can be related to a particular rental, the Dolly Blockbuster model enforces such a connection. To keep our database content consistent, we decided to only add either the relation to a customer or to a rental, since the customer could be inferred through the rental. After the lookup of one of the two, all fees and all data from credit balance are pushed to the new database. So, this were some of the more interesting issues we had to cope with in the turn of our database migration process. Hopefully we could vividly show you how we resolved these problems. But we don't want to end here without quickly showing you what this new mediated schema enables us to do. This might become clear when we show you two of our sample queries. Alright, let's see what we can do now with those three combined data sources. This query is designed to tell us the 10 most rented persons in an acting role. It makes use of the now separately stored person, which we can relate to the rentals via the actor table, the addition and copy tables. I wonder what that gets us. Yeah, seems like the classics are still the classics. No surprise here. Another example. It's definitely a classic as well, but nonetheless a very complex query. We want to find the 5 customers who generated the highest turnover for us, since they are of increased importance to our business. With our now extended circle of customers, we really need to find the key movie junkies again. Personalized advertising might not be a waste on them. Let's have a look. Ah yeah, I thought so. Mr. Dresner is as of now our customer number 1. Watch out, Mr. Dresner, we are coming for you. And that concludes our presentation for today. We, the Supergroup number 3, namely Dolly Blockbuster, BDMI and Couch Cinema, would like to thank you very much for your attention. Have a nice day and bye bye.